Okay, so it is good to see everybody. So we are finally back to where we can actually teach and interact with each other. So we're going to start with polynomial operations. That should take us the rest of this week. But Friday is the end of the 9 weeks. So remember, we did have our exam, the second exam of the 9 weeks last Thursday. So if anybody was still wanting to retake that, you still have time to do so. It's by Friday morning at 8:05. That is the absolute cutoff, because after that, I'm going to go ahead and start getting the grades ready, go ahead and posting those before the 3-day weekend, before I take off. So if you are interested, you just have to turn in the 3x3 solving systems assignment and the systems of inequalities assignment. Okay, so those two are what's needed if you're going to retake. I did the other day go ahead and give you an extra credit option, but because we were in the middle of TSIA, I really didn't get a chance to talk about it. So here it is. Okay, now there is a typo here. There's two options. If you successfully get the extra credit, you can either raise a lowest quiz grade to a 75, no retake required. Okay, so let's say maybe you failed it, it was pretty low, boom, it's a 75. Okay, no questions asked. Or you could add 7 points to any lowest exam grade. Okay, so at the bottom of the paper, you're going to check which one you would prefer to have. Now, in order to do this, you've got to successfully get minimum 3 out of the 4 questions right. Bless you. Okay. So if you do that, you get your extra credit, you're good to go. So this is due, okay, Friday 10:10 morning by 8, no, it says 8:10. I'll take it by 8:10 then. It should be 8:05. But after 8:10, not accepting it. Okay, so if you're absent, if you come in late, nope, no excuses. If you don't turn it in by that time, you just don't get it. It's just extra credit. Hey, no. So I do have extra copies here in case anybody needs one. So if you want one, raise your hand. 1, 2, 3. 1. Now, if you picked up one the other day, don't take another copy. Okay, because I don't have enough copies for everybody. Okay. Also, one other thing, it does say in the instructions, you need to show work. If all you do, these are multiple choice, but if all you do is turn in the paper and they're circled, you've shown no work, even if they're all correct, you don't get credit. Okay? Yes. You already had one? Okay. Pass that on to the front, please. Thank you, Emma. Okay, so questions on the extra credits. So extra credit. Okay. That one. 7th period. Okay. So you still have a little bit of time. Like I said, if anybody's interested, you can go ahead and do that. Okay. Well, let's finally get back to a lesson. Okay. We're going to go ahead and run through polynomial operations. So hopefully this is going to be a lot of review. Maybe if you had trouble the first time around, I can help fill in any gaps you might have. But here we go. So what's a monomial? Okay, I'm glad you asked. It's a number, a variable, or a product of numbers and variables. Some examples would be 4, 7x, 3x squared. Now, when we're working with these monomials, okay, we're performing operations, whether that be adding and subtracting, multiplying and dividing, we're going to have exponent rules that we're going to be looking at. Okay, so we have the product rule, power, quotient, negative exponent rule, and zero exponent rule. Okay, so I'm going to go ahead and be quiet for a minute, let you copy that down, and then we'll talk about it. Okay, so the product rule depends on if you have the same base. If you're multiplying terms with the same base, you keep the base and you add the powers, okay? And for each of these, there's an example over in the third column. The power rule, if you raise a power to another power, you're going to multiply those together. Okay. The quotient rule says if I've got a fraction where the numerator and denominator have the same base, again, it's got to be the same base for this rule to work. You're going to subtract the powers. It's always the upper power minus the lower. So the way I've written it, m minus n. A really good way to think about that, I've always thought it's a fraction, use subtraction. Okay. You want the best, come to the west. Okay. I'm a poet. I didn't know it. I'll stop. One of these papers? The packet? Oh, the extra credit. Oh, okay. Where did I put that? Okay, let's see. Now, the negative exponents, this is typically what students have a little bit of trouble with unless you've gotten some practice. So the idea is if we have a negative power, you're going to take the reciprocal. That's the key word. So let's pretend a to the negative m is over 1. Well, all I got to do is flip it. By taking the reciprocal, the negative power becomes positive. Now, this also works in the other direction. That's why I added this other rule out here. You'll notice we have a negative power in the denominator. Well, again, by flipping it, it makes it positive. So no expression is completely simplified if you still have negative powers. You want to take care of that. And then the zero exponent rule, anything to the zero power is going to be 1. The only exception, 0 to the 0 power, that's undefined. Okay, so I should say anything besides a base of 0. Okay, so with these rules in place, let's go ahead and start practicing some of these. Okay. So number 1, let's say I want to take 5x squared and I want to multiply it by negative 7x to the 6th. Well, we're going to multiply or use whatever operations with the coefficients just like normal. I need a 5 times a negative 7. Negative 35. Let's see, x squared times x to the 6th. We're multiplying terms with the same base. So in this case, I'm going to add the powers. Okay, so the 2 plus 6 is where the 8 came from. Bless you. Now, as we go into the next problems, some of them are going to start to get a little bigger. The nice thing about these rules is you're going to see multiple rules a lot of times will help you simplify these expressions. The good news is there's no order of operations. As long as you're following these rules, the exponent rules, you're always going to be able to get to the answer you're looking for. Yes, sir. No, you'll have to recall these. You got to be able to remember them. That's a good question. Okay, let's take a look at number 2. Now, before I can multiply these together, there's something I have to take care of. Okay, the parentheses. I've got to take care of this power right here. So every single one of these terms inside, kind of think of it as a distributive property for powers. It's only going to be a power times a power. It's never base times the power. So, for example, a negative 2 squared, that'd be a positive 4. And when you think about it, negative 2 times negative 2, right? Okay. Well, what would an a cubed squared be? Remember, what's the rule say if I have a power raised to a power? Do I add, subtract, or multiply? We multiply. So that would be a to the 6th. So right now, the power on b is 1. So b squared is just b squared. And then we have times 8ab to the 9th. Okay. See, now this is just like problem number 1 we did. Okay. So what is 4 times 8? 32. So I want a to the 6th times a to the 1st. A to the what? A to the 7th. See, I'm multiplying terms with the same base. So this is when I add the powers. So what's a b squared times b to the 9th? B to the 11th. And there we go. That's it. Okay, question. Okay, not too terrible. Okay, all right. Well, let's try this next one. So I've got 54 m to the 6th n to the 4th over 3m squared n minus 10m to the 4th n cubed. Now this one right here, that 10m to the 4th n cubed, right now there's nothing to do to it. Okay, there's no operation being applied. So I'm going to focus all my attention on this quotient here, this big fraction. Well, let's go through it one by one. Let's start with the coefficients. So I'm still going to divide 54 by 3 just like any other time. So somebody help me out. What is 54 divided by 3? Okay, that's what? 18. Okay, thought I heard something different for a second. Now, what's the rule say if I've got a fraction where the numerator and denominator have the same base? We're going to subtract. So if I've got m to the 6th over m squared, this is going to be m to the 6th minus 2. So this is m to the 4th. Now, while you can go ahead and apply that rule, typically myself, I don't go ahead and use it a whole lot. I just simplify. Let me show you what I mean. Let's take care of the n's. You've got n to the 4th over n. Okay. So how many n's do I actually have up top? Don't I have 4 n's? Okay. So I'm always thinking about it in terms of just simplifying pairs. So I can simplify one n with one of the n's above. That leaves me how many n's? 3. Minus 10 m to the 4th n cubed. So everybody okay how I got that first monomial? Okay. Even if you'd applied the exponent rule, the 4 minus 1 still gave me the 3 n cubed. Now here we have like terms. Okay, we got the same variable set and the same power set. So what's 18 m to the 4th n cubed minus 10 m to the 4th n cubed? Okay, that's 8. What? Not just 8. Okay, when you have like terms, it's only the coefficients that you're looking at. Like for example, let's say if I had something like this. Let's say I had, a 5x squared minus a 3x squared. Both of these are like terms because they have the same variable and power set. They're both x squareds. So what's 5 minus 3? 2. So the answer would be 2x squared. So even though we have a product of variables here, that doesn't change anything. We still took the 18 minus 10, but this is still going to be followed by m to the 4th n cubed. Okay, remember those are what we refer to as like terms. Okay, you only focus on the coefficients. Okay. All right. Let's take a look at number 4. I've got 2k to the 4th times 10k to the negative 7. Do you remember what I said a moment ago that it doesn't matter in what order you go ahead and approach these? Okay. I can go ahead and right now multiply those two together, or I could go ahead and deal with that negative. I can go ahead and take the reciprocal. It actually doesn't matter what path I choose. So let me show you. Let's say I'm just going to go ahead and multiply these together. Okay, so 2 times 10, that gives me 20. Now, k to the 4th times k to the negative 7, well, that's going to be k to the 4 plus negative 7. So this is going to be k to the what? K, that's a horrible k. I can do better on that. So k to the negative 3. Now, I can't leave that as my final answer. Why? Yeah, it's not completely simplified unless all the powers are positive. Okay. Now, here's the thing about this. We got to take the reciprocal, but you're only going to take the reciprocal of what has the negative power. You ever heard that old phrase, if it's not broke, don't fix it? That sounds familiar? Well, this 20, it doesn't have a negative power. So you're not going to take the reciprocal of it. You're only going to go ahead and flip the one with the negative power. So this is going to turn out to be 20 times 1 over k. Now it's a positive 3. Now just multiply those together. So I got 20 over k cubed. Only if it has a negative power do you need to move it. Okay. And a really good way of thinking about the negative powers, all they want to do is switch levels. If a negative power is in the numerator, he wants to go to the denominator, and vice versa. Okay. How are we doing? Anybody having a hard time so far? Anybody lost? Okay. Well, let's see what else we got. Let's try this one. So number 5. Okay. So it does have fractions. That's okay. All right. That's not a problem. Let's go ahead and deal with the first monomial, though. Okay. I've got to change it because that whole group is what? Squared. It's in parentheses. So the first thing I need is 2/3 squared. Okay. Well, let's think about it. What's 2/3 times 2/3? Okay. So let's see here. 2/3 times 2/3. That's going to be 4/9. Or I could have simply applied this 2 as a power to each term in the quotient, the fraction. Okay. So now this is going to be 4/9 r to the what? Oop, let me change that back to blue. So I've got r squared squared. Okay. And at least what do you think? R squared squared. Remember, what's the rule? Do I add, subtract, or multiply the powers? Power of a power. Okay, well, you got a 1 in 3 shot. Okay, so we already squared the 2/3. What happens when I square r squared? Am I going to add, subtract, or multiply those 2's? So this is now r to the 4th. Okay, now I have s to the 7th squared. Elliot, what's that going to be? I need s to the 7th squared. S to the 14th. Times. Now you'll notice there's nothing outside these parentheses. So I'm going to go ahead and say 1/6 r cubed s. Now I can multiply these together. Okay. Well, let's see here. 4/9 times 1/6, and if it helps you to write this over to the side, you can absolutely do that. Remember, we're just going to multiply straight across. So this is going to be 4 over, what's a 9 times 6? 54. Okay, so I want r to the 4th times r to the 1st, or excuse me, r cubed, I'm sorry. R to the 4th times r cubed. So that's r to the what? 7th. Now I need s to the 14th times s. S to the 15th. Is there anything else I could do for this problem? Yeah, what is a 4/54? Okay, it's going to be 2/27. So 2/27, r to the 7th, s 15. How are we doing? Anybody lost? We're doing okay? Okay. Let's try this next one. So I've got number 6, this whole quotient, 14w to the 12th over 7w cubed, all of that is raised to the -1 power. Okay. So remember, what was it I said before? Power to a power, what do? We're going to multiply. There's only 3 options, add, subtract, or multiply. So this is going to be 14 to the -1 power times w to the -12 over 7 to the -1 power, w to the -3. See, all I did was take that -1 and I just applied it to the power only of every term inside. Okay. Now, how am I going to make these negative powers positive? By the reciprocal. Well, remember, what makes it super easy, if you have a negative power in the numerator, where does it want to go? It wants to go to the denominator. Well, where do those negative powers in the denominator want to go? They want to go to the numerator. So, can anybody tell me what my final answer is? What should be up top? Remember, what are the only terms that want to go up top? So it should be 7w cubed. As soon as they switch levels, that negative becomes a positive. Okay, so what's going to be happening in the denominator? 14w to the 12th. Yeah. So see, these, they want to go down, and those, they want to go up. All I did was flip it. Why isn't the 14 what? Because see, it's not the negative coefficient, it's the negative power. The power only applies to the power, whatever the base is holding. Now, that's not my final answer, because I can still do what? Now I can simplify it. Okay. Now, let's think about it like this. 7/14, would everybody agree that's a 1/2? That's easy, right? Now, if I applied the exponent rule, 3 minus 12, well, that would give me w to the negative 9. But see, now I'm giving myself another problem. I'm going to have a negative power. So that's why I'm saying maybe it would be better. I've got 3 w's up top, 12 w's down below. Why don't I just cancel out 3 pairs? So if those 3 cancel with 3 below, see, I'm still left with 9 w's in the denominator. But if you want to go through the rule, I mean, you're perfectly fine to do so. The only thing we have on top is 1 divided by 2w to the 9th. All right. So I think at this point you're thinking, Miss West, I got this. I'm ready for one on my own. Ready? Okay. Try number 7. 15x to the 10th y to the 4th over 24 x to the 12th y cubed. Okay, now remember, you can use the exponent rule, okay, where you subtract or just simplify it. Everybody think they got an answer, or we need a few more seconds? Somebody's at the door. Hello. Okay, Betty. It says, when convenient. So let's see how much further we can get before I let you go. All right, here's what we should be getting. 5y over 8x squared. Okay. How many folks got that? Okay, that's not bad. That's a good number of hands going up. Okay, so let's talk about this. Where did the 5/8 come from? Yeah, the 15/24. 15/24, you can just look at it individually. What's the common factor? 3. So 3 goes into 15 5 times, into 24 8. Okay. Now, you could absolutely go ahead and take the 10 minus 12, give you negative 2. Then take the reciprocal, but think about it like this. I've got x to the 10 over x to the 12th. Okay. So 10 x's above are going to cancel with 10 x's below. See, that's going to leave me 2 down below. Okay. And the same thing here. 3 y's below are going to cancel with 3 above, leaving me just 1 up top. Now, one other thing I want to show you real quick, take a look at number 8. Okay. Now, we've got this, both of these parentheses are to the 4th power. Okay. But you'll notice I didn't mention this on number 6. Before I even apply the power, is there anything I can do inside the parentheses? Like if we go back to number 6, you'll notice 14 over 7, well, isn't that just 2? Okay. And then w to the 12th over w cubed, well, wouldn't that be w to the 9th? See, I could have absolutely simplified that before I even applied the power. I can do the exact same thing here. Okay, see, I'm still going to get the same answer. Okay, so let's simplify this before we even apply the power. Let's see if we can do anything. So this c over c squared, what's that going to become? Just c. Now, there is only one c left, but where is it? In the bottom. Okay, because think about it, we got one c up top is going to cancel with only one of the two down below. So this first one is 1 over c to the fourth times. Now, unfortunately, negative 3c, there's nothing to take care of there. Negative 3c to the fourth. Okay. Well, let's see what we got here. What's 1 to the fourth power? Let's see, 1 times 1 times 1 times 1. Yeah, that's 1. So if I apply that 4 to the c, remember, that's not 4 times c, it's c to the fourth. Okay. Now we want to do the same thing here. I'm only going to apply this 4 to the powers. It's not negative 3 times 4, it's negative 3 to the fourth power. Okay. So if it helps you, that means we got negative 3 times negative 3 times negative 3 times negative 3. Well, 4 negatives are going to give me a positive. Let's see, 3 times 3? 9 times 3? 27 times 3? 81. C to the fourth. Well, if I go ahead and multiply these together, I'm going to have 81c to the fourth over c to the fourth. Well, what happens? Yeah, those completely cancel. 4 c's above cancel with 4 c's below, so this is just 81. How are we doing? Hey, sure, good match. Okay. Okay. Has anybody ever seen those exponent rules before? Did y'all do that in Algebra 1? A little bit? Okay. Cool. All right. Well, now we're going to go ahead and kind of be skipping around a little bit. Okay. All right. So what's a polynomial? A polynomial is the sum or difference of many monomials. So those single terms or products, if you start adding or subtracting them together, ooh, my command hook. It's okay. Okay. That's a polynomial. Now, the one term that has the largest power, that's the degree for the polynomial. Okay. So the highest exponent of a polynomial is called the degree. Standard form, always write with the exponents in descending order. What that means is start with the term that has the largest power. Then move on to the term with the second largest power. Then the next largest, all the way down the line until you're out of terms. Okay. So like, for example, take a look at number 10. Okay. Negative k to the fifth minus 1 plus 8k minus 3k cubed plus 1/4 k squared. Out of all of those, what is the single largest power? 5. So this would have a degree of 5. Okay. So I'm going to start with the term that has the largest power. So that would be a negative k to the fifth. What would I follow that with? We don't have a fourth, so I have to move on to a, yeah. So now we have minus 3 k cubed. What would have to go next? Okay, plus 1/4 k squared plus what? 8k, and then minus 1. So see, when we put it in what we call standard form, we start with the largest power, and then we put them in descending order, always finishing with our constants. Okay. So constants are said to have a degree of 0. Okay. If anybody wants to know why, I can easily tell you that. So let's try 13. Now, what's different about 13? What's different about 11 than number 10? Okay, we got 2 variables. Okay, so that doesn't change anything. All right, we'll just go ahead, you choose one of the variables and put it in standard form for that variable. So let's say I want to do this one according to A. So out of all 4, Which term has the largest power on A? So I'm going to start with 4a cubed. Okay. Followed by what? Plus 18a squared b squared. Then what? Plus 7ab. And then we're going to finish up. The only one left is a minus b squared. There you go. That's it. Okay. Cool. All right. Well, classifying polynomials. Now, polynomials are classified by degree. Remember, that's the highest exponent. And the number of terms. Okay, so it says use the charts to the left to classify each polynomial below. Okay, so I'll give you a second. So if it's just a degree of 0, that's a constant. That's just a numerical value, no variable. Right, Brianna? Right. Okay. And then if it's a degree of 1, linear, 2, quadratic, then cubic, quartic, quintic, bless you. And then our number of terms, if it only has 1 term, that's a monomial. 2 terms is a binomial. 3 terms is a trinomial. Okay. 4 terms is a polynomial. Okay. So they do have names, but if it's 4 or more, we're just going to refer to it as a polynomial. Okay. Because we're more so classifying these by the degree than anything else. Okay, I want to keep an eye on the time. Okay, we still got time. All right. Okay, so let's run through a few of these. Let's classify these. Number 13 says negative 3x plus 1. Okay, what's the degree? What's the largest power? Okay, Miley, what do you think? It is 1. So because its degree is 1, that means this one's linear. And how many terms do we have? There are 2, so this is a binomial. Okay, so this is a linear binomial expression. Okay, we want to classify it by the degree and the number of terms. Okay, so 14, 9x to the 5th minus x to the 4th plus 2x. What's the largest degree? Well, what's the degree? Okay, 5. So this is a what? This is a quintic. How many terms do we have? So this is a quintic trinomial. That's all there is to it. How easy is this? Super easy. Super easy. Okay. Now let's try 15. What's the degree? It is 0. Okay, remember, constants, numbers, don't have a degree. Well, technically it's a degree of 0. The reason is because 24 is equivalent to this. Remember, what is anything to the 0 power? Okay, 1. So this is 24 times 1. So see, that's where I get the 24 from. Okay, so this is just a constant. And because there's only 1 term, it's a monomial. Okay. Is everybody starting to get the idea? Okay, this is not a problem, right? Okay, what's number 16? This is a cubic what? Cubic polynomial. Yes. Okay. What's number 17? This is a quadratic trinomial. Yeah. What about number 18? The degree is what? 4. So this is a quartic monomial. There's just a single term. Remember, the terms are only separated by addition and subtraction. Okay. Even if I had something like this. Okay. If I were to have negative 1/2 x squared y to the 4th z squared w to the 5th, that's still just 1 term. That's a monomial because it's all one big product. Okay. Cool. All right. We should be able to get into, or at least scratch the surface on the next one here. And I think this is where we'll go ahead and stop for today. Adding and subtracting polynomials. Okay? Well, all you're doing is looking for like terms. Okay? Now, in order to drop the parentheses, I got to distribute anything that might be there. But if you take a look at number 1, there's nothing in front of either of these groups, so I can simply drop the parentheses. 3x squared plus 11x plus 4, and then that's a minus 5x because we're adding a negative 5x, plus x squared minus 13. Okay. Now, we want to write our final answer in standard form. That means we want to put it in descending order of the powers. Okay. So why don't we go ahead and focus on those terms as we go through this? So what's the largest power? Squared. Okay, so I'm looking for a 3x squared plus x squared. So that would be 4x squared. Okay, so I've taken care of both of those. Now, especially, I don't know, this is a habit I got into a very long time ago, especially if it's a very long polynomial expression. I always mark out the terms that I've used just so I know not to look at them again. So what would be next? 11x minus 5x would be 6x. And then I got a 4 minus 13. Negative 9. So there we go. So that sum is a quadratic trinomial. And there's the standard form. Okay. Easy, easy, right? We like this. This is a good review. Okay. All right, like I said, we're going to go ahead and stop there. Fantastic. Okay. Remember to bring these notes back tomorrow because we're going to wrap this up. We should be able to get through the rest of this tomorrow. Okay. All righty. Okay, don't forget. Okay, you have until Friday morning, not only to retake, but also for the extra credit. Okay, so it has to be by 8:10 Friday morning.